Hello, my name is Martin Stute. I'm a professor in the Environmental Science Department at Barnard College, and I've been working on arsenic issues in drinking water for more than 10 years. What I'd like to do today with the sand tank that you see right next to me is illustrate the processes that mobilize arsenic and also show how arsenic gets transported into the subsurface and what we can do about arsenic problems in drinking water. So this sand tank is a plexiglass box filled with sediments such as sand, gravel and clay. The sand tank represents a vertical cross-section through a groundwater flow system. Picture the Earth's surface on the top of the sand tank and the bottom of the groundwater system as the bottom of the tank. It is like a vertical slice of the subsurface in a place such as Long Island in New York State or Bangladesh. Sand tanks are useful tools for demonstrating groundwater movement and processes such as arsenic contamination. You can purchase a sand tank and use it in class demonstrations on this website. Arsenic contamination is a problem in Bangladesh and elsewhere, where naturally occurring arsenic is released from the sediments into the drinking water supply of people using wells. Chronic exposure to arsenic through drinking water is a problem because it leads to skin, lung and other cancers. It can also cause skin lesions, reduce cognitive function and cardiovascular problems. In this first video, I will introduce the components of the sand tank, the types of aquifers and the mechanisms of groundwater movement. The video illustrates the interactions between rain, surface waters and groundwater. The second video, entitled Arsenic Contamination in Bangladesh, will introduce the spatial distribution of arsenic in the subsurface and the differences between deep and shallow aquifers. We will also look at pathogens in Bangladesh groundwater, briefly introducing additional contamination issues in Bangladesh. In this section, we will talk about the different elements of a groundwater system, the types of aquifers, and how water flows in the subsurface. In this sand tank, we have two types of aquifers. An aquifer is a geological formation that conducts and contains water. On top, we have a sand layer, which is cropping out at the surface. This aquifer is connected to the atmosphere and is called an unconfined aquifer. At the bottom, we have a gravel layer, which is separated from the unconfined aquifer by a clay layer. This gravel layer constitutes a confined aquifer because it is not connected to the atmosphere. In between, we have a confining layer that is called an aquitard. An aquitard contains water but conducts water poorly. In this sand tank you can also see wells, which are tubes glued to the front of the plexiglass tank. They are open at the surface in order to enable pumping. Some of them have small openings at the bottom where they are connected to the aquifer. Those wells are called observation wells. They are used to monitor changes in groundwater levels and quality. Some wells have a large opening at the bottom and are very well connected to the aquifer. They are used for withdrawing large amounts of water and are called pumping wells. Some of the wells are connected to the shallow aquifer and others are connected to the deeper aquifer. Lastly, we have a pond and a river that are both connected to the shallow aquifer. Water can flow from the unconfined aquifer to the river and from the river into the aquifer depending on the season. Water levels in wells or surface waters, also called hydraulic heads, are important in hydrology because they tell us something about the energy of the system. Groundwater will flow from places where the water level or hydraulic head is high to where the water level or hydraulic head is low. In a nutshell, water is flowing downhill. So, water levels are indicative of groundwater movement. Water levels in the sand tank right now are more or less the same, which means there is no movement in the system. So at the moment there is no water leaving the bottle, there are no bubbles rising in the bottle. There is no water leaving the system at the lake or river. We can change this by creating a low water level in the system by draining the river. This will create water movement in the tank. Result of draining the river, you see the water levels dropping in the wells in the shallow aquifer. The wells in the deeper aquifer are less affected by draining the river. Bubbles start rising in the bottle, which indicates that water is flowing into the aquifer. So currently the area where the water is draining out of the bottle into the sand is where water is being added to the aquifer, and we call this a recharge area, while on the right side of the sand tank in the river, where we're taking water out of the aquifer, we call that the discharge area. In nature, recharge is mostly happening by rain, and we can show this by running the outflow of the bottle over the surface of the aquifer, and water is entering the aquifer. We can visualize groundwater flow by injecting some red dye into this injection well, and over time we see the red dye moving through the sand from where recharge is happening towards the discharge area. In this segment, we will introduce the groundwater system in Bangladesh. Aquifers in Bangladesh are made out of sands and finer materials, similar to what you see in the sand tank. We'll thus discuss the seasonal changes in recharge and discharge in the aquifer system. During the dry season, the water levels are really low in the river, and the water levels in the wells are slightly higher. As a result, there tends to be flow of water from the aquifer to the river. There is some loss of water from the aquifer to evaporation across the surface. At the beginning of the rainy season, in the late spring and early summer, the rivers start to rise first because they are fed from the Himalaya from snowmelt. As soon as rivers rise, there is recharge from the rivers to the aquifer system. So we should see yellow dye penetrating the aquifer. Flow is reversed in the wet season. Shortly after the rivers rise, it starts to rain in Bangladesh in April, May, June and July. The monsoon kicks in. We simulate this by using blue dye water. We see rainwater entering the aquifer by observing the blue dye penetrating the surface. And some precipitation ends up in the pond, which could also be a place of recharge. At the end of the rainy season, the water levels in rivers and lakes drop. Note that water in the river receives a mixture of all the colors. As a result of the discharge from rivers during the dry season, the river levels are low. In order to observe how groundwater moves to rivers during the dry season, we let it run and see how the mixture of reds and blues move through the subsurface towards the river over the years. In the second part of this series, we are going to look at arsenic and how it fits into this picture. We are going to visualize how arsenic gets mobilized in the subsurface and transported in the subsurface. We are also going to look at pathogens, and we are going to visualize how people are exposed to arsenic and pathogens in their drinking water and what they can do to avoid this exposure.